So yeah, staying within the theme. I think JavaScript development today has a serious problem. We generally, for the most part, we write our programs in a fairly imperative style. We've got global mutable state on occasions, object orientation, and there's a problem with that. There's a very real problem. It's just too mainstream. It's not cool. I mean, any self-respecting hipster wouldn't want to touch that stuff, but we aren't really clear on the alternatives, are we? I mean, what kind of people would write code in a style like that? Ah, sorry, I've done this thing on. So much for my comedic timing. Enterprise developers would. Do we want to be enterprise developers? No, we do not. So we need a better solution for this. So we have this thing called functional programming, and functional programmers up in their ivory tower fantasylands, they have all these amazing words and concepts and things that you've probably never heard of. And that sounds like it's a good start. So yeah, you've got your Kleisli arrows, you've got your Yoneda lemmas. Don't know why you would need a lemma, but there you go. Burritos, we don't mention the M word, and so on. I'm going to have to pronounce the last one now, psychohistomorphic prepomorphisms, just for kicks. I've practiced so much to be able to say that. So yeah, there's functional programming, but there's all this stuff. What's the use of this? There are things, fortunately, leaking out of the world of Haskell and whatnot into concepts that are more relevant to us as JavaScript developers. For one thing, there's this thing called functional reactive programming. And in particular, this thing called Reactive Extensions, made by this guy called Eric Meyer for C# originally, and then it started spreading out into other languages. And this guy called Bodil Stokke essentially implemented the JavaScript version, RxJS. Matt, that doesn't look like you at all. Cool t-shirt though. Is that Eric Meyer? Yeah. Who's this then? I don't know, it looks cool. Probably invented something very interesting. Wait, is that the guy who killed TDD, isn't it? Yeah, good job. Anyway, so RxJS is what I want to try and use today to actually build something real. I'm just going to be, once I'm done introducing this thing, I'm essentially just going to be writing code. So we're going to build a game using RxJS. And originally, I thought I'd just use the DOM to render our game components. And then I saw Angelina's talk earlier today about the canvas, so I thought maybe we'd just rewrite this to use the canvas. And then just now, David mentioned this thing called React. So I figured, why not use that? So while he was talking, I just rewrote this whole thing to use React as a backend. That's a lie, by the way. That was prepared. So React was invented by these guys at Facebook. And it's essentially, well, it's more than just a renderer, but I'm just going to use the rendering part now, wherein you can construct sort of an immutable virtual DOM and then just push that into the current DOM. Turned out to be very cool, very easy to do. So if you're wondering about reactive extensions, it's essentially, think of arrays. You know arrays in JavaScript. You can map them, you can filter them, you can do all these really functional things with them. And in reactive extensions, you have this thing called an observable, which is sort of the same thing, except it also extends over time. So what we got here is we take an array and we turn it into an observable. And I got this helper function here called log, which just prints what comes out of the other end of the observable. It's sort of like a stream as well. So if we run this, we should be getting ponies. Ponies are cool. We can map the ponies. Ponies, map, pony. I like pony. And like that. And you see it's essentially I mean, it looks just like mapping arrays at this point. Of course, it also works over time. Got this thing here, which takes my pony observable and zips it together with an interval observable, which ticks every half second. So if we log this, we get 1 pony every half seconds. That is 2 ponies a second. That's pretty good. And further, of course, we can also keep applying these functions. They are still valid. Like, say, if we put a filter on the end of this, it's essentially going to filter every pony as it comes in every half second. So if we are only interested in ponies that end with the letter E, they should do the trick. Notice they come out a bit irregularly because there's only a pony every half second, but we only let the coolest ponies through. So we can go even further, and we can make sure that everybody knows that we love Twilight Sparkle and, of course, Pinkie Pie. And the completion there at the end is when the stream is done, because there are no more ponies. So, of course, the stream can close. Anyway, let's write some code. I got some code prepared already, just very basic utility stuff, like David was talking about immutable data structure. So I made my own implementation of the hash array map tree. Slightly simplified, but it is fairly efficient. It's ON for the SOS function. The SOS function will take 2 objects and squish them together using the hash array map tree function. Yes, this isn't really a hash array map tree, but it sounded really cool, so. And I just got a function here to clip coordinates to check if a coordinate is on screen or not. That's going to be useful later. And my bind key function, which essentially wraps the mousetrap library, which lets you listen to key events, and turns that into an Rx stream. So if I go bind key space, that's going to come out as a stream of spaces whenever I press the space key. Anyway, let us get on with it. So what you can see on the right here is the sky above Ponyville, and we also need to put some ground there for our character to run along. Actually, we should better just get on with the renderer as well. So the way I'm going to do this is I'm going to have sort of a scene graph. It's not really a graph. It's just going to be an array of elements. And the ground element, or all elements, are going to have an x-coordinate. And they are going to have a y-coordinate. They're going to have an ID, which is just going to translate directly to a DOM class. And this one's called ground. Quite a bit exciting so far. And I also got this idea of being able to offset coordinates. So if I have this thing called base x at -128, that's always going to be added to the x when we render it, just to make some calculations a little easier to follow. And we're going to have to write the renderer for that. First of all, we're going to have a function that takes a node like this and turns it into a React DOM element with a class name of node.id and a style applied, left node x plus node base x, as I mentioned, or if that doesn't exist, then 0. And of course, instead of math.floor, thank you, Angelina, we just bitwise all that with 0, and plus px, because CSS. Same thing, node base y, or 0, and there we go, that should do it. That should get us exactly the element we need. Obviously, the DOM class has some CSS attached to it, so this ground is going to have a background image set already. And then we need a function to render the whole thing. it takes a list of these nodes, like ground, and it's simply called react.render component with parentive with no properties, and for the second argument, we just give a list of React DOM nodes, which is going to be children. And we can just simply take nodes and map, make elements over that. That should do it. And we need to render component takes the target as well. And on top, you notice I find the element with the ID of canvas and puts it in the canvas variable. So canvas. And then we should be able to give that a list of nodes, currently only ground. And there's the ground. Yay! That's the doge. But the ground is supposed to move, so this is where React is going to come in handy. Sorry, Reactive Extensions. Instead of the ground object, we can make a ground stream. Let's just get rid of the object, by the way. We won't need that anymore. But we've got the rendering engine now. We create an observable. And every 33 milliseconds, that should give us, is that 30 or 60 frames? Whatever. It's going to fire off an event. And when that happens, it is actually going to be counting up from 0 to infinity every 33 milliseconds. So we can map that onto a function which takes the x, which is going to be the number, and returns an object like this. So you notice, by the way, I'm using ES6 because why not? We live in the future now. So that will be ID ground. And also, as well as living in the future, nobody wants to type that function thing all the time. Base x is at -128 still. And x is x modulo 64 times -8. That's going to keep us, that's going to make the ground scroll a bit until it's almost at the end of the texture. Then it's going to loop back and scroll, and hopefully it's going to be seamless. Y is still 384. And that should do it. Of course, we are going to have to plug that into the rendering engine. And we can do that. We could actually just map, if the render scene function just took a node, we could just map that stream directly to the render scene function. But as it takes a list of nodes, we are going to use the RxObservable zip array function, which takes any number of Rx streams. We just pass it ground stream. That's going to give us a list of just ground stream, and that we can map directly into render scene. So that didn't work at all, did it? Oh, sorry. Subscribe. I'll map it. Subscribe is the endpoint of a stream. Essentially, it takes a function and says that whenever this stream produces output, please call this function with that output. So it's like map, except it actually causes the stream to start. That looks better. Are you kidding me? Applause for the ground. Your mind is going to be so blown when the pony shows up. Speaking of which, let's get the pony in. Because what is a game without a pony? We're going to have to make a stream for that as well. First, though, we are going to make a stream that listens for space key presses. And not just that, but I'm going to buffer that, with an interval 33. what this is going to do is every 33 milliseconds, it's going to give us an array of however many spaces were pressed during that interval. So it's going to be like our frame tick, but it's going to come with key events as well. And let's get there's a pinky stream. That's going to be, oh, actually, we'll just plug something on the tick stream. We're going to use a scan function, which is sort of like an event loop just for pinky. That takes a function. No, sorry, it takes an initial state. This is going to be one of those node objects of ours. So this was called pinky. And her base y is going to be 276. That makes her look like she's on the ground when y is 0. And of course, x is 0 and y is 0. And I'm just going to add the rest of the state we're going to need to her because she is going to be affected by physics. So she has an x velocity and a y velocity. And she's also going to have a flag which says whether her game is over or not. If we get as far as actually adding enemies, but I'm not sure. We'll see. And that also takes a function which will take the previous version of pinky, and it's going to take the keys, which is what comes out of the stream that we are attached to. And this is where pinky's game loop should occur. I'm going to need a function that applies a velocity. That's going to be generalized, n is for node. We can use that for lots of things later. And we use the magic associate function from our hashrate map tree library. We apply node. Sorry, let's just call n. And to n, we apply x is n x plus n vx. And likewise for y. Right, that should do it. So now, we update p with velocity of p. Notice that because of the magic immutable data structure function, this is going to return a new object. And as long as we're inside this function, it doesn't really matter if we mutate that object, as long as it is a fresh one, as long as we don't mutate what comes out of the function. So we're just going to be cheating a bit here. For one thing, we want her, actually just, let's see if we can make her show up. Just add pinky stream to our zip array down here, and that hopefully, whoop. Yeah, we got a typo. It should be capital Y. That's pinky. And of course, wow. Of course, pinky is affected by gravity. Only because she wants to, but she is. That's 0.98, right? So, oops. Yeah. She needs to hit the ground and stop, I think. So if pinky's y coordinate is greater than 0, that will be below ground, then please make her be at 0 and make her stop. Now she stays on the ground. But of course we want her to jump. And that will imply that if the first element of the keys array is space, we don't care about the other elements. You can only press space anyway. So if we press space, then give her an upwards velocity. Make her jump. Oops, what was that? Interesting. My window manager is interfering with my key bindings, but okay. I'll just have to switch focus. So she jumps, and she can also keep jumping, apparently. Okay, so we need to make sure that she's going to come down eventually, don't worry. We need to make sure that she can only jump while she's on the ground. So I think she's going to, there she is. I'm not going to add the color braces. It's okay for Apple, so it's okay for me. That should do it. And while we're at it, actually, let's add the curly braces. Because I actually need to do more here. We're going to play some sound. When she jumps, we play the jump sound. Oops. And also, no matter how hard I press the space key now while she's in the air, she doesn't keep jumping. So that's a good start. I think that little pink is physics. Now she needs something to do. I thought that, I mean, obviously we are already inspired by a certain game, so I thought maybe Pinky would like to collect some coins. So let us add some coins. We need an initial coin object. ID coin. Vx is -6. Vi is 0. X is 1,000. And y is 40. That should give us an object that is going to come in from off screen at a certain height, which then Pinky should jump and catch. Does that sound reasonable? So we need a stream for that. Of course, Pinky is going to affect the coin. If she touches the coin, she's going to collect it. So what we can do then is essentially plug the Pinky stream into this new stream. And that's going to feed Pinky's node into our coin stream so we can respond to it. We're going to use scan again. Initial value is initial coin. And we're going to have a function that takes C for coin and Pinky. It's a bit tight here. And quite simply, use the velocity function to apply velocity. And so if first of all, the idea is that when Pinky touches it, we're going to send the coin just moving straight upwards. So we can use the velocity to detect if it has been caught or not. If it's 0, it's OK. And I got this magic function that I didn't show you, which is just a bit of math, which can let us know if two nodes intersect with each other. So this will be true when Pinky touches the coin. Of course, we need to play some sound. Coin MP3, can you guess what that's going to sound like? And when that happens, we are going to stop the horizontal movement, and we are going to send that thing going upwards. And moreover, huh? I'm missing a what? Oh, God, yes, thank you. Pair programming, yay. Okay, so if it is moving upwards, in fact, we want to increase the velocity. So it goes faster and faster upwards. And there we go. Okay. And is there more? Okay. Finally, remember the on-screen function. This is why we're going to need that. Because when the coin goes too far off screen, upwards, we just reset it. Or if you fail to catch it and it goes off screen to the left, then we also reset it. So if this off screen, on screen, sorry, then we just return C, otherwise we go back to the initial state. And of course, the initial state is not mutated because we aren't crazy. We use immutable data structures now. So let's see, we need to also add the coin to our rendering stream. Let's see if the coin shows up and if I can manage to catch it. Ooh, there's a coin. It's a Dogecoin. Ooh. And I caught it. Yay! Oh, shit. Yeah, that was handy. That was all my work done, but fortunately, I happen to have a cheat slide in case that happens. So what I'm going to do, or is that actually my code? No, it should be on top, what I'm looking for. Yes, because I was also going to add a hater. And that, as you can see, is not much code, so I'm going to just rewrite that. However, this is going to be too time-consuming to remove. I'm just going to explain it afterwards. But I'm going to add the hater stream. Much like the coin. Because, you know, us bronies, we are quite frequently bothered by haters on the internet. So I thought a hater would be a good enemy. Apparently, some people feel threatened by ponies. I don't get that. The hater moves 8 pixels to the left. And also starts at 1,000 off screen, while 300 is going to have it sort of on the ground. That should do. Terminating semicolon, just in case Douglas Crookford finds out. And the hater stream. Hater stream. Sort of the same as Pinky. Every tick, starting with the initial hater, H, and keys. It doesn't actually need keys, we can take that out, because no static type checking. We can go crazy. And the H is velocity of H, as previously. And just like coin, if the hater goes off screen, it restarts. Initial hater. Right. I'm just going to need to take out something else down here. This bit. But notice what I've done up here, though. Instead of just subscribing to tick for Pinky, I zip tick and the hater stream together because Pinky responds to the hater stream. The hater is completely unaffected by Pinky, but if Pinky touches the hater, game over. So I have squished these two streams together, and because of yay ES6, what comes in is an array of keys as before and the hater. So we are doing destructuring here, because we can now in the future. Let's see if that even runs. It doesn't. I've expected as much. C is not defined. Oh yeah, C up here. It should be H for hater, not C for coin. Thank God I am you guys. Okay. There's a hater. Whoops. See, I have 2 minutes left. I'm actually just going to... Because now, of course, she doesn't die. But I'm just going to paste this back. You'll have to apologize. I'm going to try and briefly explain it, but we are running out of time. So essentially, the same thing. If Pinky and the hater touch, and we are not in game over yet, then go to game over, move Pinky to the game over class, which gives her a different animation, play the game over sound, and send her going upwards. And if we are in game over, she's going to like go ooh, like Mario does when he dies. So instead of applying regular gravity, we apply half gravity, because why not? So let us play the game. Roll the hater. Like the haters. Where's the coin? There's a coin. This is going to be a tricky jump. But she dies. And that, ladies and gentlemen, that was a game using reactive extensions and a little bit of React, because everything starting with those 5 letters is awesome and you need to start using it. So, and I'm not going to be able to match Angelina, but I did as well as I could. So thank you very much.